Alright, before we start the next section, we're going to review the last one with a little twist. This section here, what I want to cover is adding and subtracting radicals and multiplying and dividing radicals. You guys may have some basis for this. I just wanted to give you guys a quick overview of this prior to starting the next section. Alright, so let's review last section. We have the square root of 160. We want to simplify this. Okay, so we want to find what factors can we break 160 down into. Alright, are there perfect squares that are factors of 160? Now when I see 160 I see 16, so, and 16 is a perfect square, so I'm going to do 16 times 10 equals 160. Alright, we know that 16 is a perfect square. 4 squared equals 16, so we have 4. Alright, and then the square root of 10, well, the square root of 10 is broken into 2 and 5. Alright, because 2 times 5 is 10. Alright, can we break down 2 and 5 anymore? No, 5's prime and 2 is 2. Okay, so what we're going to do is take every number radical that's left over and we're going to multiply them. Alright, so we have 4 times rad 2 times rad 5. Okay, 2 times rad 5 is rad 10, and then we have the 4 on the outside. So the square root of 160 simplified is 4 square root 10, or 4 rad 10. Okay. Number 2, we have 4 rad 27. Okay. Now when you have the number out in front, we're just going to bring that to the last part and multiply it by whatever we can simplify our radical to. Alright, and we're going to simplify this radical 27. Are there any perfect squares that go into 27? Well, there is the square root of 9. Square root of 9 times the square root of 3. Okay, we know the square root of 9 is 3. Okay, and the square root of 3 can't be broken into anything else. So we have 3 times the square root of 3. Okay, but we also have this 4, so we're going to multiply this 4 by the 3 as well. So we have 4 times 3 times square root of 3. 4 times 3 is 12, and then we have the square root of 3. Alright, now on to adding and subtracting radicals. When you add and subtract radicals, it's similar to adding and subtracting like terms, okay? Where the radicals are the variables and whatnot. I kind of talked about it in the first section. If I have 8x plus 2x, I can add them. That's 10x. But if I had 8x plus 2y, I cannot. Alright, it's still 8x plus 2y because they're not like terms. Okay, same thing goes for when you add or subtract radicals. Alright, if you have like radicals, where the radicand is the same number, you can combine those numbers. Okay, you can combine the coefficient in the front. Alright, so 3 square root 2 plus 4 square root 2, we just add 3 and 4, and it's 7 square root 2. Alright, now if we have a problem where we may need to simplify the radicals first, alright, do that first. 7 square root 7, well, 7 is a prime number, so we cannot, the only factors of 7 is square root of 1 and the square root of 7. So there's nothing to do here. We can't simplify it. We'll just leave it as it is. Alright, however, the square root of 28, we could simplify. Alright, so square root of 28, a perfect square that goes into 28 is 4. Alright, and square root of 4 times square root of 7 is 28. We know that 4 is 2, square root of 4 is 2, so we have the square root of 7 square root of 7 plus 6 times 2 square root 7. Alright, that's multiplying these two. Okay, remember we have to multiply the 6 and the 2 before we continue. So we have 12 square root 7. Alright, we have like radicals. So 7 plus 12 is 19 square root 7. Alright, same thing with subtraction. Okay, see if we can simplify them first if we can. Alright, especially when they're not like radicands. Okay, so 32, we've done the square root of 32 before. That's 16 and 2, which is 4 and square root 2. So we have 11 times 4 square root 2, which is 44 square root 2. Okay, and we're going to subtract 9 square root 2. We can't simplify the square root of 2, so we have 9 square root 2. 44 minus 9 is 35 square root 2. Okay, next one, 4 square root 12 minus 5 square root 50. Alright, see if we can simplify them. 12 is square root of 4 times the square root of 3, which is 2 and the square root of 3. So we have 4 times 2 times the square root of 3, which is 8 square root 3, minus, break down to 50. Perfect square that goes into 50 is 25. And 25 times 2 is 50. So the square root of 25 is 5. And we have the square root of 2, which can't be simplified. And we have this 5 here too as well. So we're going to multiply those. 5 times 5 is 25 square root 2. Alright. And now we don't have matching radicals. Okay, so we can't do anything with this. They're not alike, therefore our answer is just going to be 8 square root 3 minus 25 square root 2. That's all we can do with it. Alright, multiplying radicals. Alright, when we multiply radicals, we can multiply the radicands themselves and the numbers in the front, or the coefficients. Okay, so let's do that. Alright, multiply the coefficients. 4 times 2, which is 8, and then multiply the radicands, which is 3 times 6, which is the square root of 18. Okay? Alright. If your radicand is a prime number, you're finished. Alright? But if it's not, you may need to check to see if you can simplify it. Okay, so the square root of 18, I'm going to do this over here, just so I have room. Is there a perfect square that goes into the square root of 18? Yep, square root of 9. Alright, 9 times 2 is 18. Square root of 9 is 3. And we have the square root of 2. So we have 8 times 3 square root 2, which is 24 square root 2. Okay. Now when there's no coefficient in the front, it's just a 1, so 2 times 1 is 2. Okay. Can you simplify square root of 7? Can you simplify square root of 11? No, they're both prime numbers, so we're just going to multiply them. Square root of 7 times the square root of 11 is the square root of 77. Alright, is there a perfect square that goes into 77? Alright, there is not. All right, and one key that you could look at is, what do we multiply? We multiply two prime numbers. Okay, if we have two prime numbers, they can't be simplified. All right, so when we go to break down the square root of 77, you're going to get the same numbers. Okay, and which can't be simplified, so therefore you're finished. All right, and then the last part, we're going to divide radicals. So we have the square root of 4 over 25. Okay, when you divide radicals, you have to square root both the numerator and the denominator. Numerator is the number on the top, okay, and the denominator is the number on the bottom. So we have to take the square root of both the numerator and the denominator. All right, and just so happens these are both perfect squares. The square root of 4 is 2, and the square root of 25 is 5. All right, can you simplify that? No, so there's our answer. Okay, same thing here. We have to take the square root of the numerator and the denominator. Okay, square root of 3, well, there's no square root of 3. It's a decimal, so we're going to keep it as the square root of 3. And the square root of 16 is 4. So we have the square root of 3 over the square root of 4. Okay, and we're okay with that. That's fine, just the way it is. All right. The problem with division of square roots is when the denominator is still a square root and the numerator doesn't matter. Okay, if the numerator is still a square root, that's fine. But when the denominator is a square root, it's called to be improper. All right, so let's look at an example of that. All right, we have the square root of 9 over 2, which is the square root of 9, over the square root of 2. All right, the square root of 9 we know is 3, so we have 3 square root 2. Okay, now mathematically this is improper. All right, so what we do to fix this is we multiply both the numerator and the denominator by the square root that's in the denominator. In this case, the square root in the denominator is 2, so we are going to multiply by the square root of 2 in both the numerator and the denominator. Now 3 times the square root of 2 is 3 square root 2. Okay, and square root of 2 times the square root of 2 is the square root of 4. Okay, what happens here is we end up with a perfect square. All right, and it's basically kind of getting rid of the radical in the denominator. All right, when we multiply two of the same radicals, your answer is going to result in just the number inside the radical, the radicand. All right, so we have 3 square root 2 over 2. All right, last part would be to check if you could simplify this here. Just like if we had 4x over 2, we could simplify here, and that would be 2x over 1, or just 2x. Okay, here 3 over 2 we can't simplify, so our answer is going to be as it's written. All right, let's try another one. Square root of 10 over square root of 11. Okay, can't simplify either of them. Okay, 10, because square root of 10 we just learned is square root of 2 times the square root of 5, and you can't simplify that. So what we're going to have to do is multiply both sides by the square root of 11. Alright, square root of 10 times the square root of 11 is square root of 110 over square root of 11 times the square root of 11 is 11. Remember, it's just this number here. Okay, because the square root of 11 times the square root of 11 is 121. Okay, last thing you would do is check to see if you could simplify this.